Hi, Science 30s. Mr. Riley here. I'm going to put a couple of quick videos together here looking at, we're looking at organic chemistry and specifically some functional groups. So when I have a hydrocarbon and I replace one of the hydrogens with something else, we call that a functional group. And we say that because it changes the structure and the function of that molecule. Okay, and so the functional group we're going to look at today has to do with alcohols. I can take a hydrogen off of a alkane molecule, and I can replace it with what is called a hydroxyl functional group. It is an oxygen bonded to a hydrogen, and we've seen this before. This OH. We cannot confuse this with a hydroxide ion. That's the part of a compound that will give a solution basic properties. So the hydroxyl group is not a hydroxide ion. Okay. What we're going to do when we replace a hydrogen with this hydroxyl group, we're going to change the ending of that alkane name to, we're going to change it from the ane we're going to add ol on the end. So something like methane would become meth, and instead of the e, we're going to put methanol, like that. Okay. So the uses for alcohol, I know some of you kids know one use for it. It's not very good. Disinfectants, fuels, solvents, and yes, alcoholic drinks would be another, I suppose, use of alcohols. So let's look at a couple examples here. So these are two things I might ask you to do in the future here. So example one, draw the structure of pentanol. So first thing we got to do is we got to think about how many carbons is pent referring to. And some of you guys are probably pretty familiar with that. That's going to be a 5-carbon chain. So I'm going to take 5 carbons, put them together. 1, 2, 3, 4, 5. Okay. And on one of the ends here, I'm going to put an OH group. Now, I draw the OH like this. This actually, a portion of the molecule actually becomes bent. If you guys remember back, oxygen, I'll just draw it over here. Oxygen has 2 lone pairs and 2 bonding electrons. So remember, oxygen is able to make 2 bonds. So you should only ever see 2 lines coming out of oxygen, 1 line attached to hydrogen, and then carbons should have how many? That's right, they should have 4. So each of these hydrogens, I'm just going to fill in the rest of this molecule with my hydrogen atoms. And when I'm done that, I have successfully drawn the molecule pentanol. Okay, so now I might ask you something else. So I might say, okay, well, what is the name of this molecule here? And so for this molecule, I've drawn it a little bit of a different way. I actually did what's called the condensed formula. So instead of drawing out all the hydrogens around here, I actually just attach them to the carbon and tell you how many there are. So the number of hydrogens and the number of lines in my structure here, for any carbon, they should be equal to 4. So in this case, I have 3 hydrogens plus a bond. That makes 4. So in this case, I have 1, 2, 3, 4, 5 carbons. And so that's going to be pent. And then I notice here on my last carbon, I have this hydroxyl functional group. And that's going to make this molecule, wow, it's also pentanol. So I just wanted to show you sort of 2 ways that I could draw the same molecule there. And so both of those would be the molecule pentanol, which is an alcohol. Okay. Now, sometimes you guys, you might be wondering, okay, well, what if this hydroxyl group is on this carbon? It's attached to somewhere in the middle of the molecule. We would have a way that we would name that. We would call it pentan 2-all, or we could, if it was this one, it'd be pentan 3-all. But we are going to just focus on the basics right now for our online course. And so the hydroxyl group is always going to be at the end, and we're going to keep that simple. Okay? So good luck. Bye.